Hello all, welcome to Coder. Let us solve today's LeetCode daily challenge, and the problem is break a palindrome. Given a palindromic string, a lowercase English letters, palindrome, replace exactly one character with any lowercase English letter so that the resulting string is not a palindrome and that it is the lexicographically smallest one possible. So return this resulting string. If there is no way to replace a character to make it not a palindrome, return an empty string. So string A is a lexicographically smaller than string B if in the first position where A and B differ, A has a character strictly smaller than the corresponding character in B. For example, ABCC is lexicographically smaller than ABCD because the first position they differ is at fourth character and C is smaller than D. So hope you understand the problem. We are given a palindromic string and we have to replace exactly one character such that it should be lexicographically smallest by a string, and also it should not be a palindrome. So if this is given a palindrome, we have to replace one character. I can replace either either A O M or B O M or C O M and so on. Like that I can replace the first alphabet without having an M, so that this will become, now this will not be a palindrome. Similarly I can change the second position as well. Either I can say M, but this is the palindrome, so I cannot take this string. So if I change any character with the second position, this is going to be a palindrome only. So and similarly I can also change the third position, like if I change the third position with A, it will become MOA, it will become MOB if I replace with the B character, and similarly I can have several words. So I have to return the lexicographically smallest string. So obviously the lexicographically smallest string is AOM, which is not a palindrome. So this AOM is our resultant string for this problem. So what you observe is, if I want to make a lexicographically smallest string, then there will be two positions I. If there is a string MOM, or I can take another example, which is the example 1, ABCCBA. This is my example 1, right? Let us trace this. If there is a string like this, they are saying that I will give a palindrome only, but you should replace one character, and that resultant string should be lexicographically smaller string, and also it should not be a palindrome. So what will be our cases is, if there are two characters, the first and the last character, if I tend to change the last character, then obviously this string will not be lexicographically smaller. But if I change the first position of that character, that is, if first position in the sense, if these are the pair of letters, if I change the first position of the string, it will be lexicographically smaller. How is it? That is, if I replace this first character, which is not A, to A, then it should be lexicographically smaller. So you can see that this first two letters are A, so I can increment my I and I can decrement my J. But you can see that this two characters are B. If I change this to some smaller character, that will be a lexicographically smaller string, and it will not be a palindrome, because here there will be a difference between those two characters. So I can change this whole string to be in this position. I will make it as A, so this string is not a palindrome and it will be a lexicographically smaller string. And there will be another case. What will be the another case? If all the string is containing A, then what I should change? If all the string is containing A, then obviously I and J will meet at some point and it will come out of this loop. So I should change the last character to B, so that this will be my lexicographically smallest string for this input. For any input string that is containing all A's, I will be changing the last character to B, and for any input string that is a palindrome, I will traverse I and J I will move, I increment I and I will decrement j simultaneously until I found a character which is not a, and if it is not a, then I will make that character to be a, and then I will return the palindrome string. So what will be the edge case? Here the example 2 clearly states that if I cannot make a, if I cannot replace any exactly one character, that will not make a palindrome is a string with a size 1. So what I can say is, first I will take the size of the string int palindrome dot size. I have taken the string size. Now what I can check is, if my size is equal to 1, then I can just return an empty string. So this will be my edge case. Next I will define I and j. I is 0 and j is going to start from n minus 1, and I'm going to traverse only the half of the string. So I am instead of making this I less than n by 2, I am just using this I and j. How we are going to check this palindrome, like that. So while my I is less than j, I am going inside this loop, and if my palindrome of I is not equal to a, what I will do is, I will make that palindrome of I equals to a and just return this palindrome. Else what I can do is, I can just increment my I plus plus and I can just decrement my j minus minus. So this is what I'm going to do in my else part. Or I can just put like this, I plus plus and j minus minus. If my string is containing all a's, then this while loop will not be executed. Then what it will do is, it will come outside the loop. Then I can make the last character to be b. So palindrome of n minus 1 to be b. So that will be my lexicographically smallest string, which is not a palindrome. So return palindrome. So that's simple. This is the problem, and we have solved in order of n time complexity, and there is no any extra space. So let us try to submit our code and check whether it is get executed or not. Now let us try to submit the code. Superb, it got accepted. Hope you like this solution, and let me know in the comments if there are any suggestions. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.